We will be continuing with a discussion on World Wide Web. Now, if you recall, in our last class we were talking about the HTTP protocol, and we had mentioned that this HTTP protocol provides the heart of the World Wide Web. All transactions that go over the internet today, whenever a client wants to contact a web server and the responses are sent back, they are done through the HTTP protocol. So, today we will be continuing our discussion from there. So, World Wide Web part 2 is the topic of our discussion today. So, we start with by looking at the requirements of a web server. For example, if someone asks you to design a web server, so we try to address the issues that would be faced by you as a designer. What are the things that needs to be taken care of? So, let us look at the basic requirement of a web server first. Now, of course, the most basic of the requirements is that your web server must be able to accept HTTP requests, because our web is based or works on the basis of the HTTP protocol. So, the first point is absolutely mandatory, and for the majority of requests, the request type will be either GET, where you are possibly trying to fetch a web page, or HEAD, where you are trying to fetch the information about a page. And if you are supporting forms, then possibly also POST. There are other HTTP commands also, you recall, but these three are the most basic. There are put, delete, this kind of commands are also there, but these three are the most basic ones. Now, if you want to have GET and POST facility where you can submit a query string, then in addition you will have to have the facility for handling so called server side scripts. Now, server side scripts are nothing but some programs, these are executable, which are residing on the server machine. These executables can be written in any language. They may be written in some scripting language, Perl, or may be written in languages like C or Java. Okay? And whenever you submit a query string using GET or POST, these executables will get executed. Of course, which program you are trying to get executed, that must be mentioned in the GET or POST command, and after execution the outputs of these programs will be sent back to the browser or the client. Typically this will be in the form of a HTML page. So, this is a simple requirement that a web server must conform to. Now, in addition there are a few other things. Well, when a typical web server is being installed, you will find that there are some typical convention for the directory structures which are followed. For instance, there is something called the root directory. So, all HTTP files and folders are created under this root directory. Okay. So, as an example, this root directory may be /home/httpd. For some web server like Apache, this is the default web server root directory. Similarly, there will be a directory which will be located under the root, that will be called the HTTP home directory. Well, home directory is something where all your web pages would be located. Okay. So, whenever you are putting in some web pages on the server, it must be under the home directory. In contrast, the root directory is something where all the files related to the web server will be stored. Some of them may be your actually web pages, some may be other miscellaneous files also. So, typically the home directory can be something as home, httpd, docs maybe, and optionally there can be another directory under the root, under which all the so called common gateway interface or CGI script programs and other scripts can be stored. Well, again as an example, this directory can be home/bin. This is the typical name. Now for the files which are storing under the CGI bin, normally server side execute permission is provided for them, because the idea is that the files that are stored under the CGI bin directory, they are meant to be executed. They will get executed if you have a get or a post command which is actually specifying a query string and a script which is located under the CGI bin directory, for example. So all these files must have the execute permission. Whenever they are specified, the programs will start executing. Okay. So the directory structure looks something like this. So on top we will be having the HTTP root, under which all the HTTP directories and folders will be created. There would be the home directory, CGI bin directory. There can be other directories, some may be simple documentation, some may be some other library files, etc. And your web page or website that you are designing, that will be under this HTTP home. Okay. So these web folders which are shown here, they will contain the directory tree structure of your so called website. This is how the files or the directory folders are located or organized. In addition, there is something called a default web page which is supported by all web servers. There is some default web page that will get returned by the server if you are not specifying the document explicitly. For example, you consider a request like this: get, you are simply specifying the name of a site, you are not specifying the name of any file or the path name of that file directory structure. So just to specifying www.xyz.com. What this command will actually mean is that a request will be sent to the web server, of course, and the web server, what it will do, it will search in its own directory structure under the web root, and it will try to find out whether there is a file with that default name present in it. If it is found, that default file name is returned to the requesting client, and usually the default file name is index.htm or index.html. They refer to an HTML document. Now it is possible to change the name of this default file directory, because there is something called server script configuration. There is a configuration file where a number of options are there. You can simply open that file and edit. So in that file there is one line which specifies what is the name of your default page. So instead of index.htm, you can change it to, for example, default.htm. So that will be your default page in that case. Now talking about the scripts, the first thing about scripts is that they are residing on the side of the server. They are server side scripts, and as I had mentioned, these scripts, they are nothing but a program. This program may be written in any language you want. So this actually refers to a file that will be executed by the server, and the output of execution will be sent back to the client. This is how the scripts work. But how do the server know that which script to run and how to get the input data and where to send back the output? Well, there are two ways. The server script may start executing in response to either a get HTTP command where there is a question mark in the command line, or a post HTTP command. Now we shall see this in detail. First let us look at the get command with a question mark. So an example is shown here. So recall, get command with a question mark means that whatever follows the question mark, this will represent a so called query string. So there will be a number of name and value pairs separated by ampersand. For example, roll is a name, 1, 2, 3, 4 is the value, sex is a name, M is the value. So there can be any number of such name value pairs you can put in, separated by ampersand. And whatever comes before this question mark, this does not refer to a web page, rather this refers to an executable file or a script. This is how the client can specify which program to run on the server side. So, you explicitly specify the name of the script. So, here for instance, you are referring to a file called xyz.pl which is residing under the CGI bin directory. This file needs to be executed and the output has to be sent back. Now, if you look at what happens internally, the server has to identify this question mark in the query in the total command line if it is a get command, and if it finds a question mark, then it identifies that whatever file name is specified before that, that is actually a program which is to be executed. Now, it starts executing the xyz.com, this xyz.pl. It starts executing the xyz.pl program. Now, the program is written in such a way that it can read in the values of this name value pairs which were supplied as part of the parameters. Now, how these values can be read in, this we shall be discussing later, not now. And again, the output generated by the xyz.pl program, that will be sent back to the client, and as I said, typically the output is generated in the form of a HTML page, so that when it is sent back to the browser can display it in a suitably formatted way on the screen. Now, if it is a post command, it is in a way similar to get, but the difference is that the name value pairs which need to be taken as input to the program are not present on the command line, rather they are present and as data following one or more header lines and a blank line. So, there will be a number of header lines, after the header line there will be a blank line, after the blank line all the name value pairs will appear. Okay. This is the format in which post sends the data to the web server. But in post, again the name of the file that you specify, that will be the executable program. Okay. And here there is one difference from get, is that you do not limit the number of such name value pairs or the total size of the string that you can send. Okay. And here again the executable program which runs can read in the data values, but how, this again we shall be talking about later, because we know that the program has to be executed. We have explicitly named the program as part of the command, but when the program executes, how to get the values of those name value pairs, this we shall see later when we talk more about the CGI scripts and the way they works and how they are actually written. Okay. So, an example of the post command is shown here. So, the first line is the actual post command which specifies out here the name of the CGI script program, the name of the executable. Here the name is myscript.cgi, this is the name of the executable file. Then there are some header lines followed by a blank line out here, then the name value pairs. Now, this name value pairs can appear in as many lines as you want, not necessarily they will have to appear on a single line, you can break it up into a number of lines if you want. Okay. Now, there are a few points which you need to remember. First thing is that the executable program that we are talking about, the so called CGI script, CGI stands for Common Gateway Interface. Now, these executable programs can be potentially written in any language of your choice. It can be written in some shell script, this can be C shell, Bone shell, Cone shell or any other shell. It can be written as Perl, Perl is a popular choice for many. It can be written using some scripting language like ASP or PHP, these are also quite popular. They may be written in conventional programming languages like C or Java. But one thing to remember, in whatever language you write the program, you must ensure one thing, that the program when it is executing on the server side, it must have some support for execution. For example, if it is a C program, then there has to be a C compiler to compile that first. If it is a Java program, there has to be a Java bytecode interpreter. If it is a Perl program, there has to be a Perl interpreter. So, in this way. So, to run a script written in a particular language, support for that particular language should exist on this side of the server. This is what you have to remember. For example, ASP, a program written in ASP, it can be run under the Internet Information Service IIS, which is available under the Windows, but you cannot directly run it under the Apache web server, because IIS by default supports ASP. It can interpret ASP commands directly. That is why when you have a program written in ASP, you have to run it through IIS. Now, let us very quickly look at what is a proxy server and why we use it for, what are the facilities that a proxy server can provide. Now, a proxy server, we had mentioned before that it acts as an intermediary between a client and a server. Typically, in the internet scenario, the client will be a web browser like Netscape, like Internet Explorer. The web server can be some site from which you are trying to access a page. This web server is sometimes also called origin server, that is the origin of the document on the resource you are trying to access. Now, in this scenario, you are having the access through the proxy server, which is intercepting all your requests. Okay. So, whenever you want to send a request to the outside world, your request will first be sent to the proxy server. The proxy server will be sending the request on your behalf to the outside world. This is how the proxy server works, but let us see how. Well, the first thing, as I said, that it acts on behalf of other clients and presents requests from other clients to a server. The clients can be on one side of it and the server is located on the other side of the proxy server. Now, depending on which mode it is in, whether it is receiving a command from a client or sending a request to an external server, it can sometimes act as a web server, sometimes act as a web client. How? See, the proxy server, whenever it is receiving a command from a client, then it acts as a web server to the client, as if the client is sending a request to the web server. So, the proxy server accepts the request as if it is a web server, but it is not processing that request directly and locally, rather it is forwarding the request to some origin server or web server which is outside the network. Now, while making this second part of the request, the proxy server acts as the client and the server located outside, that acts as the HTTP server. So, a proxy server has a dual role, sometimes it is a client, sometimes it is a server. And the most commonly used HTTP proxy server is a program called Squid, which is freely available and it can be installed on almost all platforms. Diagrammatically, a proxy server looks like this. Typically, these user agents which are shown on this side, this part belongs to a private network. This is a private network, say N. These are 3 computers which are located inside the private network. These user agents are nothing but maybe these are simple browsers. There are some commands which have been typed on the browser and they are possibly referring to some origin server, maybe this is yahoo.com. There can be one origin server, there can be several such origin servers, okay. But I am showing just one origin server in this diagram just to illustrate. So, the user agents will be sending the request to the proxy. So, requests will be coming like this. The proxy will be forwarding the request to the origin server. So, the origin server, after processing the request, will be sending back the response to the proxy. The proxy in turn will be sending back the request to the original requesting user agent. This is how it works. Now in addition to this simple request forwarding and response receiving, a proxy server typically also contains some access rules and cache. This we shall be talking about very shortly. These are some additional information which are maintained inside a proxy server. So, talking about the functions of a proxy, first one we have already mentioned, it forwards a request. See, when it is forwarding a request, it also acts as a simple and rudimentary firewall. It can allow some requests, it can deny some requests. When someone from outside is trying to access an internal node, your proxy can stop it. So, these kind of capabilities can be programmed in the proxy. So, it can act as a simple firewall, and you can have access control through a proxy. Access control means you can allow or deny certain accesses based on contents, based on location. Now, when you say based on contents, it may be based on some string which appear in the documents which you are trying to fetch, maybe some string patterns in the website name which you are trying to access. Depending on the policy of the installation, you can set some rules that somebody should not be able to access this kind of sites or these kind of contents. Typically, these are specified by mentioning a list of strings which are okay. You can say you can only access sites which contain these strings or access the sites which does not contain these strings. So, it can be either way, you are allowing or denying based on some contents. Similarly, you can also control access based on some location. You can specify that these are the websites I do not want anybody to access from inside. So, these are some websites which are blocked. Okay. This kind of things can be done very easily. The third thing is that a proxy maintains a HTTP cache. What a cache means is that, see, HTTP requests are coming to the proxy. Proxy is forwarding the request and is getting back the requested information, maybe the web pages from the servers. These pages are forwarded back to the requesting client, but what the proxy does is that it also maintains or keeps a copy of these pages in its local disk. There is a disk area which is called a cache where these are maintained or stored. The idea is that if some client requests for a page which is already there in the cache, it need not send out a request outside and get that page again. It can be directly forwarded from the local cache. It of course saves bandwidth and allows for faster access. Okay. Now, let us talk about a very important device which is used in the internet. This is called a network address translator or a NAT. Now, the reason why we use a NAT are manifold. Well, in the simplest scenario, a NAT allows a single device. This single device can be a router, it can be a dedicated box. See, this router can act as the NAT, this dedicated box can also act as the NAT. These are available commercially. So, what we are saying is that we are allowing this device to act as an intermediate agent between the internet and a local network. Now, the local network we are calling or we are referring to as the private network, and the internet or the external network we are referring to as the public network. Now, NAT sits between the public network and the private network. So, you may argue that well, it sounds very similar to a proxy server, but well, there are some differences. This will be clear as we go into the details in the working of the NAT. See, NAT does not only regulate access, it also manages IP addresses. See, one big problem that many of us face today is that suppose if we have an organization which contains say 1000 computers, but we do not have 1000 valid registered IP addresses with us which we can assign to these computers. Rather, the internet service provider through which we have obtained the internet connection, they give us only a set of few addresses. So, how we can manage with these few addresses? NAT is one such solution. Okay. So, NAT tries to address the IP address distribution problem. The way NAT is specified and it works is specified in an RFC document. If you are interested, you can have a look at it. 1631 is the number of the document. Now, if you are using NAT, then potentially one single unique IP address is sufficient to provide connectivity to an entire group of computers. Of course, there are several variations which are possible, but in general, even if you have a single IP address with you which is a registered IP address, that may be sufficient for your organizational requirements to have access to the outside world. But there are some restrictions, as we will see later, that not all kinds of access are allowed. Maybe accesses from inside the network to outside will be allowed, but not the reverse. Someone from outside your network may not be able to directly connect to a computer inside. Okay. So, as I mentioned, NAT resides between a private network and the public network, which is the internet. Now, NAT is available as a separate box from the network vendors. Most of the routers which also connect a private network with a public network, they also have the capability to act as a NAT. So, NAT can be embedded inside a router, or you can have a separate box that can act as a NAT. Now, let us see what are the various forms of NAT, network address translation. Static NAT. Well, as the name implies, we are trying to provide a static address translation. So, what you are trying to do is that you are trying to provide a mapping of an unregistered IP address to a registered IP address. You remember, this is a one-to-one mapping, which means that if we have n number of unregistered IP addresses on n machines, then to provide static NAT you would be requiring n registered addresses. What this means is that, say internally, suppose you have 10 computers and you have 10 registers IP addresses with you, NAT will provide a correspondence between the internal computers and these IP addresses, so that with these IP addresses they can access the outside world. Now, static NAT is almost similar to providing these addresses directly to the computers. Okay. So, it is not much useful other than some very specific needs where you want to assign some fixed IP address to some of the computers inside. Like for example, inside your network there is one computer which is the web server, and you want the outside users, that means users or people who are residing outside your network, they should also be able to access your web server. So, your web server must have a statically assigned IP address. Okay. But for others you may not need this. For others you have alternatives. One alternative is to go for dynamic network address translation, dynamic NAT. Dynamic NAT also provides or maps an unregistered IP address to a registered IP address, but the difference from static NAT is that here you do not have any one-to-one mapping. Rather, here you are getting this registered IP address from a given pool of registered IP addresses. what I mean to say is here is something like this. Suppose I have with me 10 registered IP addresses, suppose I am the NAT, I have 10 registered IP addresses with me, and on the other side in the public network there are 100 computers. So whenever I get a request from one of the computers in the private network, I assign one of these 10 addresses to that computer, and as long as the request is being processed, that address will be statically assigned to that computer. But once the request processing is over, that address will again be deallocated and will be returning back to my pool. So with this scheme, I can have 10 simultaneous access connections at the same time, but we are not limiting the total number of computers that can possibly have connections to the outside world. In fact, 100 or even thousands, if there are 1000 computers, they can have access, but not more than 10 at a time. I have only 10 valid addresses with me and I am allocating them based on demand. So these addresses are assigned dynamically. You can have any number of computers, but you will be having a limit n depending on the number of addresses you have to the number that can communicate at a given time. There is another form of NAT which is perhaps the most popular. This is called overloading. This in a sense is a special form of dynamic NAT, because addresses are not assigned statically to the computers, they are somehow access permissions are generated dynamically. This again is used to map multiple unregistered IP addresses to a single registered IP addresses. See, here there is a difference. You have a single registered address, not multiple as I was discussing in the previous case. There is a single valid IP address available with me, but I can support 100 simultaneous requests from the private network. How I can do this? I can do this by using the port numbers. So here I am using port numbers. The different requests will be using different port numbers. Because we are using ports to distinguish the requesting computers, this method is also sometimes called port address translation, or PAT in short. So effectively in this scheme, each computer on the private network will get translated to the same IP address. Only difference is that they will be having a different port number. Okay. So with this kind of a scheme, you are no longer limited by the number of IP addresses you have. You can have as many simultaneous connections you desire using this scheme. Okay. This, as I said, this is widely used. So let us look at NAT overloading in some detail. So as I said that using multiple port numbers you can support several simultaneous connections. This is what is called multiplexing in the transport layer level of the TCP/IP protocol stack. Multiplexing means that a computer maintains several concurrent connections with a single remote computer, but several connections can be maintained by using different port numbers. Like for example, I can have a connection with a machine X, but effectively I can have 100 connections with X if I use 100 different port numbers. Okay. Now each of these 100 connections may refer to some different server programs, or maybe the same server program there are multiple requests coming to it. I can use different port numbers to distinguish, right. Okay. Now just recall that the IP packet header, well, including the extension header, this will contain the source and destination IP addresses and the port numbers. So the combination of these 4 elements will define a complete connection. So even if the source IP address and destination IP address is the same, if we can vary, say for example the source port number, then this 4th tuple will still remain unique. Maybe the other 3 tuples have the same values, but at least one of the values of the 4 things must change between the different connections. This is how we can ensure that multiple connections can be established. Now, some notations. We define something called stub domain. Stub domain means the private network. So, the domain which is behind the NAT, which is as part of the private organizational network, that is your stub domain. And for NAT, for this address translation, we must maintain a table which is called address translation table, or in short ATT. This ATT will have to be maintained by the router or the network address translator while it is carrying out the address mapping and also the port mapping. Well, now let us look at the issue one by one. Suppose we want to implement simple dynamic NAT, no overloading for the timing. Okay? Simple dynamic NAT means I have a pool of IP addresses. If there are n addresses, I can support n simultaneous connections. Okay? So, for implementation of dynamic NAT, let us try to see what should the ATT contain. The ATT need only contain the IP addresses of the source and the IP address which has been allocated. Like you try to understand, some computer had sent a request to the NAT. That computer suppose had an address 10.5.6.7 say. The NAT assigns a valid address to it, and in the table makes an entry that 10.5.6.7 has been assigned an address this. So, for all the requests which are coming, there will be an entry maintained in this table. Now, what this table will allow? It will allow outgoing connections of course, but it will also allow incoming connections. Why? Say, as long as an entry like this remains in the table, you can have a connection from the outside world coming to you. If you see that that request is destined to an address which is called 10.5.6.7, then you can possibly forward that request to the destination machine, because you know that this particular address is there. But there is a problem. If you are saying that the request is coming with a 10 dot address, which you may recall that refers to a private address, maybe the external routers will be discarding them. Okay? So, the packet may not reach the NAT at all. So, what you can do, instead of advertising this private address to the outside world, you tell the outside world that, well, my NAT has given me this IP address and has assigned me this. So, you please connect me through this valid IP address. Maybe there will be a valid IP address 203.10.5.17 or something like that. The outside agent will be using that IP address. The ATT will provide the translation and will be forwarding the request to the internal machine, internal host. So, using dynamic address mapping, you can have some of the entries in the table fixed statically. Say for the web servers, I gave an example where you need a permanent address which is known to everybody, but the other addresses can be dynamically assigned and changed during the duration of a connection only. So, in this way you can have the best of both worlds. You can have some addresses which you need to be accessed from outside, and with the other IP addresses available you can provide dynamic access from the internal nodes, but you cannot have the other way around. A node from outside, a host from outside cannot directly access an internal node if it does not have a statically assigned IP address stored in the table. Okay? Fine. Now, in this scheme port numbers are not needed, but when you talk about NAT overloading, you require port numbers. The scenario is like this: the internal network, as I said, it possibly has non-routable IP addresses or private IP addresses, which if it appears as a destination address in a packet, a router will ignore it. A router cannot forward a packet to an address which is a private address, it will simply ignore it. NAT enabled routers or a NAT box will contain a registered IP address which will be assigned by the internet authorized access provider, address provider IANA. So, this one single IP address will be sufficient. Now, suppose the scenario is like this: an internal host, say X, tries to connect to an outside web server. So, this request will first reach the router will receive this request packet from X. Okay. The router will now save the IP address of the requesting computer. This is a private IP address, please recall, and the port number which the computer was using while sending this request. This can be obtained from the packet that was received from X. It saves these two into the table, address translation table, and in the packet it will replace the IP address which was the private address with the router's IP address. Replace the port number by the port number if the entry was already in the table, or if it is a new connection you are trying to make, you generate a unique port number. So, you are basically modifying a packet by changing the destination IP address and the destination port number. Some internal computer was sending the packet to the router or the NAT. The NAT changes the address of the packets to some address of the outside world. Also, the address of the source is changed because the request has to come back. Okay. Now, if the source address still is that private address, the request cannot come back. So, it changes the source address by the valid IP address that the router contains, and also port number is a unique number that it generates automatically. So, on the other hand, when a packet comes back, the destination port number of the packet is used to search the ATT. So, destination port number, as I mentioned, was assigned automatically and uniquely. So, that port number will uniquely identify an entry in the table, that you can say that will act as a primary key of that ATT. Okay. So, from that table you can obtain the source and port numbers, source address and port numbers. You can accordingly change the source addresses of the IP packet, and finally you can forward the packet to the host which was there in the internal network. So, finally the packet will get forwarded to the computer from when the request had originated. So, a typical table, this address translation table may look like this. Well, the first column is not really necessary, but for documentation purposes it is sometimes kept. Source computer names are stored here. When a request comes, the source computer addresses are stored, and also the port numbers which the source computer was using. The NAT IP address, there is only one address, so this will be the same, and the NAT generates unique port numbers for every outgoing packet. So, whenever an incoming packet comes, it will come with this particular address as the destination address, but this port number will be the distinguishing factor. So, whenever it is coming to port number 2, then through this table lookup, NAT will change this address to this particular address and port number 2 to port number 75, and will be forwarding the packet to the internal network. This is how through this table the NAT can provide address translation dynamically. But one thing to remember, this overloading, although it appears to be a very powerful technique, but the only problem is that you cannot allow a permanent address through which an outside host can access means one of your internal servers. Suppose you have one web server, you want to have a public IP address available to it. Through NAT you cannot do that, because all requests are processed dynamically by assigning a port number to it. So, if you want to have this kind of facility also, then you have to mix static NAT and this kind of overloading, where some entries in the table will be permanently fixed, some entries will be assigned port numbers and processed dynamically. Talking about the maximum number of concurrent translations that a NAT may provide, this is primarily determined by the memory size, the size of the memory that we use to store this table. Just to show a simple calculation, a typical entry in the ATT may take around 160 bits. So, if you have 8 megabytes of memory available with you, then for every request you will be needing about 20 bytes. So, if you make a calculation, these are the total number of bits divided by 160, this will come to more than 4 lakhs concurrent translations, which means you can have so many entries in the table potentially, and port number will never be a constraint for you, because port number is a 16-bit number. You can have up to 65,000 distinct port numbers. Okay. So, the number of distinct port numbers you can have, that will ultimately provide the upper limit. And talking about which addresses to use in the private network, there are some private address classes which also had mentioned before. Let us very quickly brush through it. This has been set aside by the address assignment agency as non-routable, means these are unregistered. Routers will discard these addresses if they are used as destination, which means that a packet from a host within a private address can reach a registered host, but not the reverse, because if you are trying to have the reverse connection, then the address of that private network has to be there in the source part, which the routers will ignore. So, from the private network you can reach an outside host, but not the reverse. In order to achieve this, you have to have a proxy server or a NAT sitting in between. The private address classes, just to brush up, there is one class A address 10 dot. There are 16 class B addresses 172.16 through 172.31. There are 256 class C addresses 192.68.0 up to 255. So many addresses are available to be used as private addresses. Depending on the size of your organization and requirements, you can possibly select one of these and use a proxy server or a NAT in conjunction with this to provide access to the outside world. Now, other benefits of NAT, well, NAT automatically creates some kind of a firewall between the internal and external networks. Why? Because NAT only allows connections that has originated from inside. An outside host, just as mentioned, cannot directly establish a connection with an internal host, because an internal host is having a private address, and an outside host cannot directly specify that particular private address to initiate a connection. So, for cases where you need inbound mapping, as I mentioned, just for web server for example, you need static address assignment in those special cases. So, in general you can have a combination of static and dynamic address mapping to have this flexibility, some address statically assigned, some address dynamic. A question which sometimes arises is that, is NAT and proxy server the same? Well, technically speaking, although they work in a similar way, they are not the same. Why? The main difference is that NAT is transparent to both source and destination host. Neither the source nor the destination need to know that a NAT is present, but rather in case of a proxy server, for example, if you are accessing the internet through the proxy server, you have to explicitly mention the name of the proxy server and the port number it is using in the configuration for your browser. That is something which is not transparent, which you must explicitly specify that this is the proxy server I want to use. And the another difference is that NAT works in the network layer and a proxy server works at the transport layer or above. So, with this we come to the end of today's lecture. We shall be now looking at the solutions that were posed for the problems of the last lecture, and we shall also be presenting some quizzes for today. So, let us first look at the solutions to the quiz questions on our previous lecture. The first question was, why is the traditional HTTP protocol called stateless? This we have mentioned that it is stateless because the HTTP server immediately closes a connection after completing a transaction and no history is maintained. But again, you just recall we had mentioned that you can have an option either close or keep alive, where you can specify whether you want these kind of stateless transaction or connection as default, or you want to have a persistent connection where the connection will remain active over successive transactions or requests. What is a hypertext? Hypertext is a text which contains some documents or text, of course. It also contains links to other texts. These links to other texts are called hyperlinks. Now, in the context of the World Wide Web, the pages that we see on the browser, they are mostly hypertexts. They are usually typically written in HTML. There are other technologies also, but HTML is most popular. What is the default port number of HTTP? Which is port number 80. What does the client request to a HTTP server comprise of? It consists of several things: request method, path portion of the URL and the version number. They must appear on the same line. Depending on the command, depending on the request method, you may have optional request headers. If you have an optional request header, then there will be a blank line followed by some additional data if you want. For post and put request methods, you need this additional data. So, all these things taken together are the components of a client request. How can the get command be used to submit forms? Well, this again we had mentioned today, by including a question mark after the path name and including a query string after that question mark. What is the purpose of the head command? To return the header information of the specified document, because in many cases the client does not need to have the full document, rather the header information. This may be used for a number of applications cases. There is one application I can just cite. For instance, in case of the web search engines, when they try to maintain and update their database, they simply look at the header rather than the complete document. So, the header should contain some information which may be useful for the search engine to update its database. In what way is post different from get when data has been sent to a common gateway interface script? Well, if you recall, in post we do not send data as part of the header line, rather there will be the header lines, then there will be a blank line as the delimiter. Following the blank line, you specify the query string. Now in case of post, the size of the query string can be larger than get. For get, it is limited to the maximum size of this string that the machine where the server is running supports. Typically it is 256 characters. How are the data sent in post command? Well, after the blank line, following the header lines. What does the connection field in the HTTP request header signify? Well, it specifies whether you want to have a stateless kind of a communication or so called stateful, whether you want to close the connection immediately after transaction or whether you want to remain or retain the connection across several transactions. What does a typical HTTP response consist of? Response is similar to a request, only difference is that the initial request header is not there, but in place of it there is a initial response line. Following the response line, there will be some header lines, the blank lines followed by the requested data. So, the remaining part is quite similar to a request, the initial response line is only different. What are the basic differences in the HTTP 1.1 version from 1.0? Well, the differences are host identification, default support from persistent or keep alive connection, content negotiation, request a part of the document, caching. These are the additional features which the version 1.1 supports. How does a proxy server act both as a client and a server? Well, it is a server when it is receiving a request from an internal client. It is a client when it is forwarding the request to an external origin server. What is the URL syntax for FTP? For FTP, it will be starting with FTP, then it will specifying the username and password followed by colon, then this @ symbol followed by the path name of the document you are going to transfer. Now, the questions from today's lecture. Well, which HTTP commands can result in the execution of server side scripts? What are the differences between root directory and home directory in a web server installation? What are the main purposes behind the use of proxy servers? Name 2 web servers and 1 proxy server that are widely used. In static NAT, on what factors will the number of registered IP addresses depend on? For NAT overloading, what are the typical entries in the fields of the address translation table? Which of the fields would not be required if it is only required to implement dynamic NAT? Can a machine with a private IP address communicate with the public host in the outside world? So, these are the questions from today's lecture. In our next lecture, we shall be starting our next module on web page design. We shall be starting with discussion on the hypertext markup language HTML, which is so popularly used for designing the web pages. That we shall see in our next class. Thank you. Today we shall start our discussion on HTML, which is the de facto language for designing web pages. Although today we have several other alternatives available with us, but still HTML remains one of the most popular choices when it comes to the design of web pages. So, today actually we shall be starting with the basic structure of an HTML document. What are the different things, what are the different so called tags and attributes that a typical HTML file can contain, and we shall see in our subsequent lectures what are the other features that we can support as part of HTML. So, the first thing is that HTML, the full form is Hypertext Markup Language. So, there are two components to this name. One is hypertext, other is markup. Well, hypertext we had already talked about earlier. Hypertext is a kind of textual document where you can have links to other documents. In HTML, this kind of links are allowed. So, in that sense, HTML is a hypertext document.